This is the second equation to calculate the entropy change, or delta S. This equation can only be used to calculate the entropy change during a phase transition. Actually, this equation represents 6 different equations because we have 6 phase transitions. Depends on what kind of delta S you're looking for. You can pick one of the 6 equations. For example, if you want to calculate the entropy change during a phase transition from a solid to a liquid, you use equation 2.2. If you want to calculate the entropy change during a phase transition from a gas into a liquid, you choose equation 2.4. I want to emphasize, when you calculate the entropy change during a phase transition, the temperature you can use must be the phase transition temperature. For example, if you want to calculate delta S vaporization, the temperature you use must be the boiling point temperature. You cannot use any other temperatures. Let me use an example to explain how to calculate the entropy change, or delta S, by using equation 2. First, we will read the problem and summarize the most important information. When I say the most important information, I mean numbers with units, what we are looking for. If you have a chemical reaction, you need to write down the balanced chemical equation. Let's start now. What is the entropy change delta S when 60.0 gram of dry ice change from solid to gas at its normal sublimation point, negative 78.5 degrees Celsius? This is the mass. This is the sublimation point. And this is the standard entropy of sublimation. This is what we are looking for, the entropy change delta S, because we are looking for the entropy change of 60.0 gram of dry ice, change from solid to gas. So I'm going to put down delta S next to the mass to indicate we are not looking for the delta S of 1 mole of substance change the state. Next, we are going to conduct some analysis to see if we can find any hidden information. And also, we want to know what kind of calculations we need in order to find the solution for this problem. When we read change from solid to gas, from what we have learned in class, this is the phase change we call sublimation. So, we may need to use equation 2.3 to calculate. Let's see if we have enough information to use equation 2.3. Standard entropy of sublimation is already given. And the sublimation point is given in degrees Celsius. But this equation requires the temperature in Kelvin. We can convert degrees Celsius to Kelvin. So, we have enough information to calculate the standard entropy of sublimation. But we are not looking for standard entropy of sublimation. We are looking for the entropy change of this many grams. If you recall, we learned another equation. We can convert the molar entropy change to the entropy change. If you recall, we have learned in class, the standard entropy of sublimation is one form of molar entropy change. the standard entropy of sublimation. We can also call that is molar entropy change because it is a change of entropy for 1 mole. In class, we learned the equation molar entropy change multiply the moles equal to the entropy change. We already get the molar entropy change from the previous calculation. If we know the moles, which we don't, but we know the mass, we can convert the mass to moles if we know the molar mass. Okay, because it says it's dry ice CO2, so we can do this calculation. From our analysis, we know this is our step 1. We convert the temperature to Kelvin. And then the second step, we calculate the standard entropy of sublimation, which is a form of molar entropy change. The third step, we convert the mass to moles. Then the last step is we plug in the molar entropy change and the moles, we can get the entropy change. Now let me show you the details of all steps. Let's start from step 1. After you plug both numbers into a calculator, we get 194.7 Kelvin. Step 2. We will plug in the standard enthalpy change and the sublimation point. This standard entropy of sublimation is one form of molar entropy change. The reason I rewrite this equation is to help me to memorize. The molar entropy change is 0.129 kilojoule per mole per Kelvin. You can also convert this to joule per mole per Kelvin. Step 3. We need to convert the mass of carbon dioxide to the moles. We need to calculate the molar mass of carbon dioxide. This is the molecular formula of carbon dioxide. If you look up a periodic table, carbon is here. The atomic mass of carbon is 12.01. You have 1 mole of carbon. And for the oxygen, the atomic mass is 16.00. We have 2 moles of oxygen in the molecule. So we multiply by 2. This is 44.01. The molar mass has the unit of gram per mole. We have 60.0 gram of carbon dioxide. Gram will cancel. We get 1.36 mole of carbon dioxide. Then step 4. We will plug in everything. Delta S equal to delta S m multiply n. The molar entropy change is 129 joule per mole per Kelvin. The moles is 1.36 mole. Mole cancel. We will get 175. The unit is joule per Kelvin.